Today I'm going to show you how to use the cut optimizer. So basically this cut optimizer serves for manufacturing of 1D materials such as metal pipes, steel bars, aluminum extrusions, aluminum bars, aluminum pipes, basically anything that is 1D material, one-dimensional material that is only optimizing length, and also specifically using for rebars in construction industries especially. So even if you're using rebars, this app is actually very usable for you and is very useful for you. So the cut optimizer is basically cutting optimizer for tubes and extrusion. It minimizes waste and maximizes yield, and also it minimizes material usage. So how does it work? So it's a curve aware cutting optimizer for extrusion tubes and bar stocks. Upload your cutting list, set parameters, and get optimal layouts instantly. So what you have to do is basically go to the optimizer and open your optimizer. So before that, it'll ask you to sign in. You have to sign in with your email, and then you have to approve your email, and then only you can log in into this page, which is this page. I'll talk about it in a while. So before that, once you go to the home page, you have to download how to use cutting list, stock count, and override. These three files here down here from the sample files are really important, and this is what you'll be using for the cutting optimizer. So how do you go about? So first of all, we will look at the cutting list. This is the cutting list. So basically cutting list consists of ID, length, quantity, name, angle 1 and angle 2. So what is ID? ID is basically for material type. It can be a round tube, square tube, rectangular tube, or anything. Or it can be a rod, it can be a bar, it can be anything you want. It can be material from the construction industry as a rebar maybe. It can be as simple as T20 bar or T10 bar with a 40H hardness, or 40D or 60D. It can be anything, so you can name it as you want. But what you have to do is do not change your name that was placed in your cutting list here. Whatever name you have in your cutting list, make sure it follows in your stock count as well. So the same file that you download from the stock count, this is how it should look like, and in the ID of the stock count it should reflect the same name from the from from the cutting list itself. So if you see it's exactly the same. You just have to copy the cutting list name and you have to paste it here, which is a round tube 25 mm 1.2 6000 mm. So the spacing, the capital alphabet, including all the alphabet spacing, everything, you need to match it in your cutting list, in your stock count, and also in your override. So basically what you can do is copy your cutting list, your cutting list name. You can simply copy it and paste it in your stock count. Once you have got your stock count ready, you can copy all of this and then you can paste it in your sample overrides. And then you can go ahead to modify all the other details. What you should not do is you should not change the headers of these files. Do not change ID, do not change length, do not change quantity, do not change name, do not change angle 1, do not change angle 2. Do not change any of these headers, including for files such as stock count and also for override files. Do not change the headers, just edit those files. That's what you need to do. So let me explain what is cutting list. So cutting list consists of the material types, which is this, and then the length. Basically this is your cutting length that you want, and this is the quantity of those cutting lengths that you want in specific. So for 2279 mm you want 1600 cuts, and the name of those cuts, the name of those cuts that they belong to, this is where it's important. So basically this naming process is basically to group those cuts accordingly to the name of those products, or basically the groups that you have identified those cuts with. So basically if you have a product which is called as arch spindle, and then you want to place those cuts as 2279 mm into this files. So you can simply name it as arch spindle, and each of those cuts will be processed as arch spindle. I will show you the example in the later part of the video. And angles does not matter for rebar users or construction industry, because you would not handle angles, so you can simply ignore this. Or if you are a construction company, you can simply if you are a manufacturing company, you need to use this, which is angles. Angle 1 stands for left angle and angle 2 stands for right angle. The reason why we have two angles is basically because you have a left cutting and you have a right cutting, so you need to know both the angles for both the cutting process. So you have to specify the angles. And let's look at stock count. So stock count is basically the stock counting for each of those materials. So for all those materials from your cutting list is basically here. So you do not have to repeat those cutting list materials multiple times like how is in the cutting list. If you can see, this 12 mm 1.0 6000 mm has been repeated multiple times, but we do not repeat it in your stock count, because your stock count is basically reflecting your material stock quantity. So basically for 12 mm 1000 6000 1 mm 6000 mm, you have a 6000 length. The length of the stock count is a must to proceed to produce here. So you have to specify all the length of these stocks, so which is 6000 6000 5700 5700, and 6250 is basically a stock that was not included in your cutting list. This is an example to show you that whatever in your cutting list is only that matters in your stock count. So that if you have something additional in your stock count, it's okay, because you want to use it for your future. If you want to use it for your other cutting list, it's okay to have it. So you can simply put it into the cutting list, and you can have a variety of range here actually from your stock count. So in the stock count, there's also quantity. So quantity stands for the number of materials that you have in stock for those materials. So like this, we have an example of 2000. So if you have 2000, it's basically, yeah, it doesn't has to be precise. It could be 2000, it could be 3000, maybe 1000, maybe 500. But the reason why we have placed here as 2000 everything, it's because that we want to standardize the process, so that you can find the exact quantity of materials that you need at the end of the day. So it's okay to set a higher number so that you can estimate the quantity that you want from the cutting optimizer. So the cutting optimizer basically shows you the number of quantity of materials that you would need to do this cutting process. So yes, do you have this? And now in the stock overrides, in the overrides file. So the overrides file, basically ID is the same as your stock count. The ID from the stock count is basically the same thing. So you have the same numbers here, the same details you have here. So, and the stock is basically the stock length of each material. And curve is basically the loss of material due to the blade's thickness. So it's simple as finding out what is the thickness of your blade, and you can find out what is the value of the loss in your material. And tolerance is basically is when you have a, I'll give you an example, because this you will not understand it in regular terms, so I'm going to give you an example. So just say if you have a 2000 mm bar, and then if you're cutting it down into two pieces, which is 1000 mm, and you have a curve of 5 mm. Curve is basically the loss of material due to the blade thickness, right? So if you're cutting 1000 mm from a 2000 mm bar, you're going to have a leftover of 995 mm. So if the 995 mm, mathematically it does not match 1000 mm required piece. So with the tolerance of 5 mm, which is plus minus 5 mm, so now the 995 mm would be considered as 1000 mm, and it would be considered as the second piece of the cut. The reason why is because tolerance is where it kicks in and it gives in a 5 mm additional value to the bar, which is the leftover, which is 995, and makes it as 1000 mm. But technically in the production environment it would be still considered as a 995 mm, and because you have given a 5 mm tolerance, so it would be considered as 1000 mm bar. And start is basically the start trim and end trim. This would not be a play for BBS, bar bending schedule users, or even for construction industry. Clamp zone is basically 30 mm. It can be anything. It can be anything that you want. It can be set to anything that you want. So clamp zone is clamp zone. And minimum scrap value is basically the minimum value of the scrap value that you would want to consider it as a scrap. So if it's below 100 mm or 100 mm and below, it will be considered as a scrap material and it would not be used for future use again. Price per bar, as said, is the price of each material. Price per cut is price per cut of each material that you want to set. And so that's it, we are done for this. Let's look at our optimizer itself. So now we can go into the optimizer. We'll go into the app. Okay, so now in the app area here, what we can see is we have to upload the cutting list and upload the stock count, and we have to upload the per ID overrides, which is the override Excel file. Okay, so how do you upload? Simply just choose a file, go to your okay, what we'll be doing here, we will be using the existing cutting list from the samples. So we'll be running the sample files here, stock count. So as you can see, those stock materials, and the reason why I mentioned that, you need to make sure that those alphabets and the spacing and the names are exactly the same. It's because those names here from the cutting list is exactly what will be mapped out in the optimizer to the stock count list. So it has to match this. It has to match. If it doesn't match, it will not be able to identify, and you're going to get insufficient results from the optimizer itself. So it has to match. So that is the reason why I told you to just copy and paste them. That would be the best answer and the best way to use this. Same goes to sample overrides as well, to override files as well. So you just have to copy your stock count IDs and paste it into this file. And then let's go into overrides. Okay, so basically now you have already mapped out your cutting list has been mapped out to your stock count, and then your per ID overrides file has been mapped out as well. You can just double check here. Round tube 12 mm, 1.0 mm thickness, 6000 mm length. This is the values. You can just cross check with your file here, the overrides file. So 12 mm, 1 thickness, 5 curve, 5 tolerance, 10 start, 10 end, 30 clamp, 100 minimum scrap, 9.5 dollars, 0.5 dollars. So this is the value, and you can see the price here as well. So 9.5 and 0.5, 100 minimum, clamp zone, and start, tolerance, curve, and stock. So yes, you have to mention stock twice, which is once in the stock count you have to mention the stock length value, and again in the ID overrides as well, you have to mention the stock length value. So there's two times here, one, two. So this is the first one, this is the second one. Okay, so you do need to mention it twice. And so once you have done already, just an additional info, which is global defaults. What is global defaults in this environment here is that you can set a global per ID override, which is the default stock length, curve value, tolerance, start trim, and so on. You can set it as a default setting for all your materials. for all your materials from your cutting list, you can set it as one go into this. This is usually done for rebar users, could be useful, but still, you know, you still need to specify your bar price and price cut. So I would still suggest to go back to per id overrides, use the example files, and you can edit them and you can reuse them. Yes. And again, let me remind you that this whole process of cutting optimizer does not utilize inches, it only uses millimeters. So please consider this before you use your files. Please convert them into mms before using them. Okay, and these values here optimized by material or cost efficiency, it does not matter, it's usually material efficiency. And use per remnant, everything is actually done without even considering this. I mean, do not change any of this. Curve counting, do not change this, you do not have to change. And strategy, you can choose balance by waste or tubes or balance, but usually balance is the best answer. So you can simply run the optimization already right now. Okay, we have got everything in place. So the point that I would like to make here is that once you have uploaded your sample cutting list, you will get this part here which is detected, and for stock count you'll have detected, and for overrides Excel there'll be an automated filling up of these spaces here. So you can see those spaces are all filled up, so you know that they have been detected. So you can simply run optimization right now. It probably takes a few seconds to maybe a minute, but usually in a couple of seconds it's done. This is the optimization loading bar. So it usually loads for a couple of seconds, but it's done in a while. So okay, now do you have tubes that was used is 3509, and efficiency it's at 91.73. This is where actually the cut optimizer stands out, because if you are doing a manual cutting process, this optimization process is not considered in your process at all. So your manual cutting process using your own techniques or even Excel sheet or even other optimizers, they usually do not achieve this 91.73% of optimization result. So this is actually very high, and your waste materials is actually this much, 1716 mm, and your material that was used is actually 60,168 mm, and cuts total was at 12,800 cuts. Total you have 729.68 parts. So yes, so and this is the per id usage summary, which you have 3,200 pieces from this rectangle tube, and you have a number of tubes that was used as 534, your stock value, and so on. And you can see per id breakdown as well for each material, how it was used at this place, per id tube breakdown, how it was used. But what matters to you is actually the stock count. So whatever you have optimized from this process here, from this stock count, from this existing stock count, this is your starting point, you can actually update it back into your stock count, and then you can download back an updated stock Excel, which would look something like this. So this is the updated version. This is how it would look once you download it. So you have a remnant piece, which is the offcut or the balance piece, which is at 4010 mm at one piece, and you have a balance of 6000 mm, which is the unused or the untouched piece, which you have 1466. And as we can see, we did not use in the cutting list this 6250 mm, so you still have 2000. So that is why I told you whatever is in the cutting list is only what matters in this process. So if it's not in the cutting list, it would not be deducted from the stock quantity or the override Excel. You can have an extended version of your stock quantity and also your your override file. So you can have them, and so that you can use it as multiple times as you want into the same optimization process. So from the 12 mm, for the 12 mm tube is where you have multiple sizes that was cut down, and you can see it has perfectly rejected 100 mm minimum scrap values out of the list, so it stays at 102 mm. So anything below than that was considered as scrap and was not considered as a remnant to reuse into this process. So these items would be, you can reuse it into this stock count. You can simply upload it back into stock count. You can simply upload it back into stock count, and you can further optimize with your future cutting list. You can upload another cutting list and you can future optimize, and with it will, what it will do is that it will, instead of using 6000 mm at first, it will reuse all your remnant pieces which is at 4000 mm, 492, 102, 115. All this would get used up first before you touching, even before even touching your 6000 mm piece. Okay, so this is it for stock count, and you can simply download you can simply, okay, since we have changed this file, it has run out, so let's put it back. Okay, it's the same thing actually, because we have changed the file, so the process has changed. So we want to get back the same results. The results are consistent with this this cutting optimizer. So that is why we would recommend this for rebar users and also for industrial users purpose, because you can handle up to 25,000 cuts, and also it's able to produce back the same results consistently. So this is where it would matter to you. For rebar auditors, you can use the download the Excel file of the results, and you can see the clear breakdown of the files. I mean the clear breakdown of the cuts and the number of usage of materials and everything. And for end users, for for workers at your station, at your cutting station, this is where it would matter. Download the layout PDF, which I have already downloaded here. So you can see the breakdown of each piece, each material. Here you can see, so 534 tubes, 800, 690, and so on. And this is the material cost, basically the deduction from the total material length and what was used. So this is the material cost, and this is the cut cost, and this is the total cost of it. Total cost is basically the total cost of cut cost plus material cost. So this is where you see the breakdown. So as per tube, round tube 25 mm, 1.2 mm, 6000 mm. This was the stock length, which is 6000 mm, and what is usable is 5980. The reason why it's 5980 is because we have set a start trim of 10 mm and end trim of 10 mm. So once you have minus out 10 mm and 10 mm from the back and front, you have only left with 5980. And curve value is we set at 5, so this is why it has deducted the 5 mm, and tolerance was at 5. So I will show you the play of 5 mm tolerance later. So now let's see how did it place the cuts for this 2279. So this was the two cuts that was placed here in the usable area of 5980. So from the 5980, after minusing the two cuts, this is where you are left with your balance, which is 1412. 1412 mm. This is the balance of cut area. This could be put into the stock count and be used later on for future cuts. So you have this, and yes, so these are the angles that we had to specify in the cutting list earlier. So the angles would show up only if you have specified them in the cutting list. So if you did not specify them in the cutting list, they will only show up as 0. So this is how you can make use of it for rebar users. So you don't need to use angles, so you can just leave it as 0 and it would still show you only as 0, so it does not matter to you. But for factory users, for manufacturing side, of course this would be usable, so you can still use it. If you have filled up your cutting list with angles, then definitely it would show up. The lower part here is the left angle, and the upper part here, the upper angle is the right angle. Left angle, right angle, left angle, right angle, right angle. Okay. Okay, now let's look at the curve where the tolerance has kicked in, and let's try to study a little bit on it. Okay, for the round tube of 12 mm, 1.0 mm, 6000 mm. Okay, so what you can see here is that uh, actually this is a case where sometimes the description, the description has gone out of the box areas. It's because when there's too many cuts, so the wordings gets pushed out of the box. So but what you can do is, I mean, what you understand from this is that this wordings belongs to each box here, so it moves backwards towards the right, it moves towards the right. So what's on the left belongs to the right, so this one belongs to this box here. So this name here belongs to this box, this name here belongs to this box, so it goes to the right. So as we can see, there was 12 cuts at total, which is 510 mm, which is 11 cuts, and 318 mm was the last cut that was placed. Then what happened was, when the last cut was placed, it exceeded the total usable length, which is 5980. It exceeded by 3 mm. This is where tolerance has kicked in. So when it's plus minus of 5 mm, it would consider the last piece, even though it is below the cut length, it would still consider it as a usable length because you have given it a 5 mm tolerance. That is where I told you the play comes in. So that's how you see that it can be used. So the actual length of this cut size is actually 598, I mean it's 3185, but it would be considered as 318 3 sorry 31315, but it will be considered as 318 because you have given it a tolerance of 5 mm. So the 3 mm would be considered as a negligible tolerance. So now this piece here is actually 315, but due to the tolerance, it's considered as 318. As I told you, it moves to the right. So this is the piece, this is the last piece. And for CNC machine users, there is another additional file for you, which is CNC layout. You can simply just download it as well. Okay, so in the CNC file, you can see those tubes that was used: tube 1, tube 1, tube 1, cut number 1, cut number 2. This is the tube. This is the same tube that was used again for cut 2, and this is the cut length. As we did not mention angle, so the angle would not be there. So if you have mentioned angle, angle would be there. As you can see there, you have angle here. These are the tubes and this is the usage. So this could be directly fed into the CNC system. So that's it for today, guys. Thank you for watching. If you have any questions, you can leave a comment and I would reply to you. Thank you.